Okay, so the other thing you need to learn is how to do matrix multiplication. So we saw last time that we could add together matrices, and when we add them together, we know that this entry and that entry go together to give you this entry here. So that's nice and easy. So this is matrix addition. So the next thing we're going to look at is multiplication. And basically the rule of matrix multiplication is that you have to multiply all the entries of the first row, so this is the first row, with the column of the second matrix. Okay, and I'll explain this in a bit more detail. And that is going to equal one entry. Okay, so you're going to go this one times this one plus this one times this one plus this one times this one, and then that's going to give you this value over here. Okay, so it does require a little bit more effort, but it's not too bad. So let's choose two matrices. So let's go 2, 3, 1, 2, which is the matrix for the slope of the lines that we had from before, and we want to multiply that by this matrix here, 4, 2, 1, 3. Okay, so what we're going to do is we're going to look along this row here, and we're going to multiply each entry down this column here. Okay, so the way I kind of think of this is you go along the row and you dive it down into this row here, and basically what we're doing is what's called the dot product. So the dot product is basically if you have two vectors, a row vector and a column vector, you're going to multiply each of these entries and then add them to each other. So let's do this. So we go 2 times 4, we add that to 3 times 1, and that gives us our first entry. Okay, now we get this row here and we dive it down into the second column. So we go 2 times 2 plus 3 times 3. Now we're going to take the second row over here and we're going to dive it down into here. So how does that go? 1 times 4 plus 2 times 1, and let's put it into this second column. 1 times 2 plus 2 times 3. Alright, so basically you can see that what this is doing is basically trying to figure out all the different combinations of multiplication that you can have between these two matrices. That's one way of viewing it. So we'll just multiply it out. 8 plus 3, 4 plus 9, 4 plus 2, 2 plus 6. And that's going to equal 12, 13, 8, and 8. Oh, 6 and 8. Oh, I can count. There we go. So this here is the resulting matrix here. Alright, so that's all you need to know for matrix multiplication. Now, in terms of, how does that even what does matrix multiplication mean? How do we actually use it? We'll go into that next. One of the applications is that you can multiply, say, a whole bunch of positions of atoms. So let's say here we've got positions of an atom. This is the oxygen atom, and it's got an x, y, and a z coordinate. And you can have maybe the carbon atom, and it has another x, y, z coordinate. And so you can describe, say, a whole molecule in terms of its x, y, z coordinates. And so you'd have an H there as well. And if you were to multiply this matrix here by another matrix, you could do things like rotate the molecule. So there's rotation matrices with cosines and sines, and you can rotate it by an angle. You can flip it, and basically this in Chem 310, you look at a lot of these different operations on molecules, and you can work out symmetry from this, the symmetry of the molecule. And you'll later see that symmetry is very, very useful, because it allows you to see whether the integral or the sum of two functions will actually give you a zero. So it means that you can simplify the maths quite a lot. But we'll get back to that later. So that's just an introduction to matrix multiplication.